Okay, so we're back in Excel, and I've already entered some data. It's actually real data from my house. And what it shows is for each month of the year, for a given year, it shows the average monthly temperature for that month. And then it shows the number of therms of natural gas that I used. A therm is a measure of volume of natural gas. It's how the gas company keeps track of it. So as you can see, in January, I used a lot more therms than I did in August because I was heating my house a lot more in January than I was in August. I also used the therms to heat my hot water. So even when it's warm, I still use some hot water. I also use natural gas in my stove. So I'm always using some. But obviously, heating the house is what really drives up the number of therms of use. So I want to do some other calculations here. So my company charges me $15, a fixed fee every month. So I'm going to enter that $15 here. And then they charge me a quantity per therm. And that year it was $1.30. What I want to figure out is how much I paid each of these months here. So what we're doing is something a little different than what we've done before because our formula, we wanted to keep referring back to these same two numbers here. But we want to be able to change these numbers and see what happens when we change them. So here's the way we do this. So we're going to say that the total amount I'm charged is equal to, so first we need the equal sign for the formula. Then we're going to do $I, $2, plus $I, $3 times C2. And we're going to hit enter. Okay. So we get 466.1, which is what I'm saying. That's what the gas company charged me when they charged me a $15 fee, no matter how much gas I used, plus $1.30 per therm. So now I'm going to copy this formula down and I'm going to explain the use of those dollar signs in 1 minute. So as we look here, we see that when we copy down to the next line, we want the I2 and the I3 to stay the same. We don't want those to change, but we want the C2 to change to C3. So notice now when I click from cell D2 into cell D3 that everything stayed the same in the formula except we went from C2 to C3. The reason that these didn't change, even though I copied the formula down, is because of these dollar signs. So if I want it always to be referring to column I and row 2, then I need to put the dollar signs in front. And so now you can see that whereas before when we copied the formula, the cell references all changed, now we're seeing that the cell references that were preceded by the dollar signs don't change, but the cell reference where we didn't have the dollar sign, those do change. So when we click here, we're at C3, C4, C5, etc. And so now what Excel did was it took each number here, so let's say it took 313, it multiplied that by 1.3 and added 15 to it and gave us this here. Now we're going to call this column, let's say total cost, and we will bold that. And the other thing we want to do is we want to format these numbers. So we select that group. We are going to select currency, and this time we'll have 2 decimal places because we're talking about dollars and cents. And so now we have it in terms of dollars instead of, in this case, we didn't want any kind of currency or anything like that. Now I also want to select this group here, and I want to get the total. So when Excel does something that makes it nice and easy. When I select a group of cells, and then I just click on the total symbol, which is this symbol right here, Excel will take the next available open cell in the column and it will put in the total. I can do the same thing here and it gives me the total for the year. Alternatively, I could have done this. I could have selected both sets at the same time and done the sum symbol, and it would have done both of them at the same time. Now, what's nice is that, let's say I were investigating, well, what would happen to my cost if the per therm went from $1.30 to $1.25, and my fixed fee went from 15 to 20. When I did that, all of these calculations changed here. My total changed. So if I wanted to explore the different possibilities or the different outcomes as these numbers change, all I have to do is change these numbers, and every single number that depends on them in the formula will change. And it makes it very easy for me to see what happens in what they call what-if scenarios. What if I change a certain number? Okay, so now another thing we want to do is, well, let's look at our average temperatures here. So we're going to make a graph. We select these cells here. We've selected month, average monthly temperature, and in this case, we're going to use a line graph because that makes sense, because we can sort of see what happens over time. Not surprisingly, we see the average temperature increasing until it peaks in the summer, and then it hits its low points at the end of the year in December, and then January and February. Okay, but suppose instead of that, what we want to look at is the relationship between average monthly temperature and therms to see whether we can find some kind of a mathematical formula that relates the two. In other words, if we know the monthly temperature, can we predict the number of therms? So what we're going to do is we're going to graph those two columns. And in this case, we're going to do a scatter plot, because when we're graphing these ordered pairs, we're graphing individual points, so we want to use a scatter plot. This is what it looks like. And so now we can see a general relationship here. And what we see is that as the temperature increases along here, the number of therms used decreases. No big surprise here. But what we're going to do now is we're going to click into here, and we're going to go to chart, and we're actually going to click right inside here. We're going to go to chart, and we're going to add a trend line. In other words, a line of best fit. So when we click on add trend line, Excel brings this up. We have different choices here, but it looks pretty linear, so we're going to pick linear. We're going to say in our options here, we'll talk about going forward or backward in a minute. We'll set the intercept. We're not going to set the intercept at 0. We're going to just let the intercept, the y-intercept, be whatever it is. We're going to display the equation on the chart, and we're going to display r squared, which is a measure that goes from 0 to 1, depending on how close a fit the line is to the points. 0 meaning that the line doesn't fit the points very well at all. 1 meaning it fits it perfectly. Okay, so now when we click, we now have, we can move this formula up, not very big, but we see that we have an equation here, and it's that y is equal to 7.0463x plus 529.63. R squared is 0.8908, which means that we have a pretty good fit here. So now what this tells us is that if we wanted to make a prediction, well, what if the monthly temperature was 43 degrees? Well, now we could use this equation here, and in fact, let's go and look at our predicted cost. And now we're going to say that our predicted cost is equal to the number of therms, which is C2, times times negative 7.0463 plus our y-intercept of 529.63, and we'll get our predicted cost, and well, something's wrong with that. C2 times, oh, it should be times, excuse me. It should be not times C2, not the number of therms, but times the average temperature. Okay, much better. Then we'll copy this down, and we'll compare the predicted cost to the actual cost, or rather, I'm sorry, this is the predicted number of therms. This is not the predicted cost, it's a predicted number of therms. And we can see that it's pretty close, but certainly not exactly the same. But this would allow us to say, well, if we have predictions for what the weather will be like next year, we could make predictions about how many therms we would be using. And then once we know the number of therms, we could do the same thing with this as we did with these, and we could find the costs. So we could say, let's take this cost here, and we'll copy it. And now we'll drag this down. And now we would have our predicted costs given these average temperatures. We could now go in and change these temperatures. Let's say that we're predicting a colder year next year, and we could see what our predicted costs would be based on that. So again, just to review, we have the months, we have the average monthly temperature, we have the therms. This is all data that I entered. The cost here, we calculated by taking the number of therms, multiplying, in this case, originally we had 1.30, which was the actual amount I paid, and 15 was the actual amount I paid. And we took the number of therms, multiplied it by 1.3, added 15 to get the total cost. Then we created this scatter plot, found the equation of the line of best fit, and then we used that to find the predicted therms, and then we used the formula for cost to measure not the total, the actual cost, but the predicted cost based on that monthly temperature. The value of that would be if we wanted to predict costs in the future. We could also change the fixed fee or the per therm cost if we knew that those were going to change in the future.